Hey everybody, this is Mr. Beckstrom, and today I want to take a look at an example from section 10.4. This is number 8, and it says find the center, the transverse axis, the vertices, the foci, and the asymptotes. And then they want us to graph the equation. So we got a lot of stuff going on here. So notice that our y and our x here are being added by something, and that tells us, first of all, that the center of this hyperbola is not at the, oh, by the way, this is a hyperbola, but the center of the hyperbola is not at the origin. So let's use the formula where it's not at the origin. So here, notice that the y comes first. That's going to be important for a specific reason we'll talk about in just a second. So we're going to have y minus k. Remember, the k always goes with the y. That's the k is the y value of the center, all over, and then underneath here we're going to have a squared. A squared always goes under the first term for the hyperbola, and then we have a minus. The minus is what distinguishes this between a hyperbola and an ellipse, and then we're going to have x minus h, I forgot to put a little squared there. Squared all over b squared. Squared is equal to 1. All right, so now let's kind of match this up with what we're given and identify all these variables here. All right, so h is going to be equal to the opposite. There's a minus in the formula. It's opposite whatever is over here, so that's a plus 5. So it's going to be a minus 5. K is equal to the opposite of this value here. So that's going to be a positive 3. All right, HK, and then we have A. A squared is equal to 16. And remember, for A, B, and C, we're only looking for positive values. So the square root of 16 would be plus or minus 4, but we only care about the positive values. So that's 4. B, we can do the same thing with the 25 there. So B squared is equal to 25, therefore B is equal to 5. And the only thing left I really need to find here is C, because they're asking for the foci. So in order to find C, we're going to use the formula. I'll do this off to the side here. A squared plus B squared is equal to C squared. And I think in the book they give it as a squared is equal to c squared minus b squared, which is just the same thing, but I like to do it like this because if I'm solving for c, it already puts c by itself. So c is equal to the square root of a squared, which is 16, plus b squared, which is 25, so that's 41. And that is our c right there, just the positive version of that, remember? We don't look at both positive and negative, so we're talking about these shapes, specifically the hyperbola, the ellipse, and the parabola. All right, so this right here is the square root of 41, and we'll use that to locate our ellipse. All right, so let's go ahead, start trying to graph this thing and use what we know. So first of all, the center is going to be at HK. So that's going to be at negative 5, 3. That is our center. That is the middle of the two vertexes that we're going to have. All right. So 1, 2, 3, 4, 5. 1, 2, 3. Somewhere around here. That's going to be our center. Now we have to now kind of decide whether this thing is opening up and down or left and right, and we can see that by which of the variables x and y comes first. So in this case, the y comes first, and that means it opens up and down, kind of parallel to the y-axis there. So our transverse axis here, that's going to be the y-axis. And this thing, and that means that this is kind of opening parallel to the y-axis. So this means this thing is opening up and it's opening down. If the x came first, it would be opening left and right. So let's go ahead and figure out where the vertices are for the hyperbola here, the upper vertice and the lower vertice. Well, in order to do that, well, we're going to use the value under the y there because we're using the y-axis here. And we're going to use the a. The a is going to tell us how far we go up and down. So we're going to go 4 units up and 4 units down along the same, and I'll just do a little dotted line here. This just shows that this is kind of the axis or the line that we're using in order to find the vertices, the foci, and the center. So we're going to go up 4 units, 1, 2, 3, 4, to right here. And we're going to go down 4 units. So we're going to end up here at -1. And then this thing is going to open something like this. We don't know exactly sure the shape of the bowl until we do a little bit more work. But it's going to look something like this so far. All right, so our vertices would, all we're doing is adding and subtracting 4 from our y value of our center. So vertices is going to be, both of them are going to be -5 because it's still on that line there. And then 3 plus 4 is 7, so that'll be our upper vertice. And 3 minus 4 is -1, so that'll be our lower vertice. All right, now our foci, we're going to do the same thing, going from the center, except we're going to be using the square root of 41 instead of the 4. So the c is what we use to find our foci. So the foci, excuse me from being all over the place, we're going to do the same thing. So they're both going to lie along that vertical line that goes through x equals -5. And then the y value, since this is not a whole number, we can just write this as 3 plus the square root of 41. That will be our upper foci, upper focus. And then we're going to do 3 minus the square root of 41. And that will be our lower focus. Now, if I want to, and I want to graph this correctly, I can take my calculator out and I can do 3 plus the square root of 41 to get kind of an idea of where that is. And I can also do 3 minus the square root of 41. So that's going to be about -3.4 and 9.4. So we're already up to 7 here. So we got to go a couple of more somewhere over here and then somewhere down like there. So that's where our foci are. And the foci really don't help us graph this unless we have like a ruler and we can actually do measurements, because the foci is really part of the definition here. And going back to the exact definition, using the foci, and oops, just a moment here, and we can find that on page 676 and 677 how the foci relates to defining the hyperbola here. All right, but finally, kind of the tricky part here. So we got the vertices, we got the foci, we got the transverse axis, we got the center. We need the asymptotes. Now the asymptotes always go through our center, and they are going to kind of go kind of lower left, upper right, something like this, and upper left to lower right, something like this. Now the way we find these is we make a rectangle. We make a rectangle, and we're going to use this is finally where we use the B. The B helps us with the rectangle. It tells us to go how many units to go in the non-transversal axis direction. So, you know, we went up 4 units here, and B is 5, so that means we're going to go 5 units this way. So this will bring us right here at y equals 0, up here. And then if we go 5 units this way, we're going to be somewhere over here. And we're going to get this rectangle that goes through both of our vertices. And it also It's from the center. It goes up and down the distance of A, and it goes left and right the distance of B. So how do we find, and what are these for? These are asymptotes. So if we dealt with asymptotes before, we know that they're used in the graph to help graph the lines that kind of go towards infinity. So let me erase these a little bit. So now that I know where those asymptotes are, I can do a better job of graphing my hyperbola. So this one here is just going to kind of go this way, following this asymptote. This one's going to go that way, following that asymptote. This one's going to go this way, following this asymptote. And this one's going to go this way, following this asymptote. Now, how do I find the center? Well, I know two things, right? I know that it goes through this center point here, and I know that it goes up 4 and over 5 for, we'll call this one y1, and for y2, we know it goes up 4 and to the left 5. So with a point and a slope, that begs the point slope formula. So quick review, point slope formula is y minus y1 is equal to m times x minus x1. So for the one that goes lower left to upper right, we're going to have y minus 0 because it goes through the center there, is equal to the slope of that is up 4 over 5. So that is going to be 4 over 5, 4 over 5, and x minus, oh, not y minus 0. That is wrong right there. I'm sorry. I was thinking of one that originated at the origin. Y minus the y value of this right here. So the y value of that is 3. So y minus 3 is equal to 4 over 5 times x minus the x value of our center, which is negative 5. So the first one's going to be set up like this. This will be our y1. Therefore, you can go ahead and simplify that and put that into y-intercept form if you want, and then y2. So y2 minus, we're going to use the same points, is equal to negative 4/5. Remember, it goes up 4 into the left 5. And that would be x minus that negative 5 there, which could end up becoming x plus 5. All right, guys, that's it. If you have any questions, please let me know, and I hope you have a great rest of the week. Thanks.